61A Lecture 27 Q&A. The first question was whether parentheses always indicate a call expression and whether adding a single quote before them, an apostrophe, converts that call expression into a list.
It is definitely the case that an opening parenthesis causes a call, unless there's something special here, in which case it's called a special form, which kind of behaves like a call, but always has some tweak on its behavior. But if you don't have some special form keyword there, then this is the beginning of a call expression. So what's the story with quotation? Well, that basically says, don't do this thing, just talk about it. That's supposed to be the metaphor. And so kind of like how you quote something in prose. So this won't make the call. Instead, it will just output the call itself, which happens to be a list containing the symbol F and the numbers 2 and 3.
So a couple of things. So I think, let me make sure we understand the question. So the question is, write a function that takes as input a list and returns the sum of the even numbers. So as John starts to do his magic, let me just say, you're absolutely right that the syntax and scheme is a little weird. It's okay, that will come quick. The concepts, I think one thing you can do, by the way, is make sure you can write it in Python. And once you can do that, it's really just a translation problem now. And that syntax will come. It's a little awkward. I always find scheme, like all the parentheses make me a little crazy in scheme over time, and it's hard to sort of keep track of it. And one of the things you'll get good at is figuring out how to indent and space your code so it looks like sort of a Python-like program, yeah?
Yeah, that's a great point. I mean, you mentioned that scheme seems to have a steep learning curve, and it will not feel natural to you the first hour that you work with it. That is true. And I think that's true of most programming languages. Even if they look kind of familiar, there's always some tricky parts that take a little practice to get used to. So the way this course is structured is that there isn't a whole lot of lecturing about scheme. I mean, we're kind of done with that. But we do give you a series of labs and homeworks and discussions just so you get like enough practice that it starts feeling familiar. And it is true that a lot of what you know applies, but everything's just slightly different in terms of the syntax, and so you got to get used to that. Okay, so how would we define some evens? So we're going to take in a list. It might have some even numbers. It might have some odd numbers. If I put some odd numbers in here, then it doesn't change the answer.
Right.
Is the idea. And
right.
I wrote them in order, but they aren't necessarily in order.
That's
so
right.
I think it's a good idea to have some notion of whether something's even or not in advance, and we could like test that. The scheme convention is actually to name procedures with a question mark if they return just a true or false value. So if you want to know whether some number n is even, well, we got to figure out the scheme way of doing this, right? So this might actually be built in. I guess we should check. Is there even? Oh, I guess there's even built in. Okay, so it kind of does what we'd expect. This is the symbol for a true value in scheme. There's like a built-in true, and there's a built-in false. But we could write this too. I think that there's a operator to do modular arithmetic. Oh, it's not called mod. What is it called? Remainder?
I thought it was
called remainder. So one way to implement this would say, is the remainder of whatever we're trying to figure out n divided by 2, 0, that would make it even, 1, that would make it odd. So if I did want to define this, I think I would write it as, is the remainder of dividing n by 2 0, and there's a built-in 0, or you could do equals 0, that would be fine too. So, and the way I work in scheme is I kind of check stuff as I go along. So now I've made my own even. Does it do the right thing? It seems to do the right thing. Okay, so now I have a piece. Now we're going to try to sum the even numbers within S. We're going to do it recursively. Basically, how you process all lists in scheme is that you treat them like linked lists, which you already know about. And most linked list processing is either recursive or with a while statement. But we don't have while statements, so I guess we're stuck with recursion. That means we do something with the first element unless there is no first element, and then we have to decide what to do. Okay, so if it's the case that S is empty. And how do we say that? Well, the most common way to say it is to say if null S. That basically is a way of saying is S this special empty list called nil in Scheme. Then what is the sum of all the even elements? Well, I'd call that 0. That's kind of the basic sum identity if you don't have anything to sum together. Otherwise, you have to figure out how to make this sum. Well, here we have to decide, is the first element in S in the sum or not? If even car S. Car S is Scheme's version of first element, and here's how we check whether it's even. If it is even, we want to add it to the result. So I would say plus car S, and then we need to sum the evens in the rest of S. So there's a recursive call. Sum evens in the cutter of S. What if S is not even? Well, then we don't need to really subtract it. We just need to ignore it. And therefore, sum all the even numbers in the cutter of S, and that will give me the same thing as the sum of the evens in all of S, because the first number is odd. Now we can see what this does. If I try to sum evens 2, 4, 6, I get 12. And if I try to sum evens 1, 2, 3, 4, 5, 6, I also get 12. All right, looks pretty good. Yeah, good question. So the question is, how come there's no lambda in here, and where's the function? When you write define, and what comes immediately after define is stuff in parentheses, a combination, you are defining a procedure, which is the same thing as a function, just the Scheme speak. So if you define just a symbol, you're not building a procedure necessarily. If you really wanted a procedure, you'd need a lambda. But if you were ever writing a parenthesis right after define, what you are building is a procedure. So now I have an F, which is a procedure. If I call it on 3, then I'll add 4 to it. And writing this is really just, shorthand for a lambda is one way to think about it. This would do the same thing.
Oh. So this is the same thing as in Python, right? We could write it as an explicit function or as a nameless function, right? So the same way, yeah. It's just the syntax is just slightly different.
The next question was about a specific example of building a list out of an existing list. So we ended up just doing a bunch of examples related to that. So let's just go through and do some list examples where we build things out of the cons operator and the nil and some numbers and see what we get and why. Writing cons 1 to cons 2 to cons 3 nil is a lot like in Python writing link 1, link 2, link 3. Or if you wanted to put in link.empty here, you could, but that part, if you recall, is optional. But that's like the equivalent of nil. This just builds a list. Scheme lists or linked lists. And so if it's always the case that you're consing a number with another list in that order, you're not going to get any nesting at all. The only time you get nesting is if whatever expression you put in this element position evaluates to a list itself. So you asked about one example. What if instead of a number here, I have an expression that evaluates to a list? This is like there instead of the number 1. And what this builds is a list that contains 4 and 3. So now we have a list with, as one of its elements, a list. This cons is just continuing the list without building any nesting into it. So if I put a 1 here and a 2 here and a nil, then I get a nested structure. Looks just like this, except for instead of 1, I have 4, 3, because the expression's the same, except for instead of a 1, I have 4, 3. So that's kind of the story there. If I already have a list, I can use that in the place of a number. I mean, I can write any expression I want. It's just a question of whether this evaluates to a number. If it evaluated to 1, I'd be building this. If it evaluated to a list like 4, 3 or 1, 2, then I would be building a list of lists. So this expression gives me a 2-element list. There's that structure of it's a list. Here's the first element. Now we continue. Here's the second element. It just happens to be that the elements are both lists.
So now let's do the first line in the chat and notice why it's different, right? So notice where that S is in the first line. You're building up this list. The first element is the list 4, 3. And then the last element is, well, that's just the list 1, 2. So you're just appending a new element to the remaining list. Yeah.
Yeah, good question. Are symbols different than strings? I mean, they're kind of an impoverished version of strings because you can't put spaces in them and you can't put new line characters in them and stuff like that. What's special about them is that they can show up in code. So like you would never have a name like an identifier or a variable in Python that had a space in it. And likewise, symbols can't have spaces in them either. So sometimes they're used like strings. We'll do that in this course just so that we don't have to talk about strings so much. In Scheme, the full language, there are strings that are supported. You know, there's like double quote marks to delimit them, and they can have spaces and new line characters and stuff like that. So you'd probably use that if you were going to like, you know, write some program that really had a string interface to it. But for simple examples, symbols are sufficient. A good question. So the question is, what's the difference between unquoting versus evaluating something? It's the same. To unquote means to take part of an expression that has been quasi-quoted and evaluate that part. So in that sense, unquoting and evaluating are the same thing. Now, evaluation happens automatically by default. So if I type +1, 2, it doesn't result in a list containing a symbol plus and a 1 and a 2. You get the number 3. That's kind of how Scheme works, is that as you're processing Scheme code, things get evaluated along the way. So quotation and quasi-quotation are a way of presenting that. If you have some longer thing, I want 3 minus 2 gives me 1. If I quote that whole thing, then I end up with a nested list. It is true that if I had that nested list, and let's say I gave it a name, I could then ask Scheme to evaluate it as if it were code, and it would tell me 3 minus 2 is 1. Quasi-quotation gives you a little bit more control. Instead of just saying, I want the whole thing quoted, or I want the whole thing evaluated, you can say, I want this part to be evaluated to give me the number 3, but I want to keep the -3, 2 structure intact. So, you know, it's not a new idea to unquote, it's just to evaluate. But what's new about it is that within some larger structure, you can pick which parts get evaluated and which parts don't. Oh, good question. So what's the relationship between unquoting and repr in Python? I think the roles are a little bit different. So repr will give you back a string that if you were to evaluate it, you would get kind of the value that is described by that string. And when you unquote something, you get the value that you get when you evaluate it. So I guess there's kind of one more step in Python, right? It's like if you got the repr string of something, you would then have to evaluate that thing in order to get a value, whereas unquoting kind of does the evaluation immediately. Yeah, great question. So the question is, in Python, can you generate code like by quoting stuff? And the answer is yes, but it's not done very often. So Python code doesn't look like a bunch of linked lists. It looks like all kinds of stuff. You know, it's got colons and a mixture of parentheses and commas and all sorts of like square brackets and various things like that. It is definitely the case that if you have an existing value and then you build a string that describes some expression about it. Like I have a string that says, I want to start with S and I want to slice it, but how much do I want to slice it? Well, I kind of want to start somewhere around 2 minus 1, and I want to keep slicing to the very end. I can build a Python expression this way through string manipulation. And then I could evaluate that in Python, and it would be as if I had just written this piece of code and asked Python to evaluate it. So yes, Python has this functionality as well. Lots of programming languages don't. Python draws a lot from the Lisp tradition, in fact, and so it has this kind of thing. But building Python expressions is just basically harder and more awkward because there's so much variety in the syntax. It makes it much easier for humans to read, makes it a little bit harder for machines to process. The next question was what a call to print returns in Scheme. Good question. So how will we figure out what this evaluates to? I think we would try to bind the result of printing 1 to some symbol. Notice here that the 1 has already appeared. And what is S anyway? Oh, it's like it's not there at all. What if we try to print it? Well, we get this special value called undefined. It's kind of close to Python's none, except for here's the rule. This is like more of a conventional rule than enforced by the language, but here's the rule, is that you're never supposed to do anything with the undefined value. Whereas in Python, people use none for all kinds of stuff. They like compare whether something is none, etc. That basically never shows up in Scheme code. So when you get this undefined value, which happens to exist, the idea is you should never do anything with it. You should never check to see if it's equal to another undefined. You should never check to see how many undefineds there are in a list or something like that. You should just stop. So basically, like, this expression is legal, but it's a no-no. You should never take the value of print and do something else with it. A follow-up question was, what are the properties of this undefined value? Is it true or is it false? Yeah, so is undefined a true value or a false value? It, I guess, is a true value in the interpreter that we use, but this is just an implementation detail. It might be that in someone else's scheme, it would be a false value or would give you an error.
Yeah,
so,
I thought that was going to give you an error. So that's something in the underlying interpreter that's different.
Right. So the idea of undefined is that the scheme specification for how Scheme's supposed to work doesn't say anything about it. Is it true? Is it false? When you add it to 12, what happens? It's just something you shouldn't ever do. In like certain versions of Lisp, they check very carefully to make sure that you never use undefined. So like this would probably error and this would error. In our version, it's there, but its behavior is as it's described, undefined. So you should never really count on its behavior being true about Scheme. It just happens to be true about the interpreter that we're using. Okay, so great question. The question is about this example from lab where you have a procedure which takes X, Y, and Z. If it's the case that X is true, then it returns the value of Y. Otherwise, it returns the value of Z. And then we have this example that's like, if 2 is greater than 1, which is definitely true, then we want 5. Otherwise, we want print 7. And since this is true, you're expecting to get 5, which we will. And the question is, how come it also prints 7, which it does? When, if, for example, I had just written this, I wouldn't see the 7.
So before you answer, John, can you do if 1 is greater than 2, and let's see what happens? This may give us a little bit of an insight into what's happening.
Sure. If 2 is less than 1, we just see the 7. And that's true in this case as well.
Okay.
This is behavior that's entirely similar to Python. The story is that before foo is called, you evaluate all of the sub-expressions in order to figure out what to call foo on. And as a byproduct of evaluating this one, you print out 7. So before the body is even acknowledged, before the scheme interpreter even really knows what it's doing, it's already figured out that 2 is greater than 1, that 5 is a number, and it has already printed 7, which is much like you'd get if you defined foo in Python, XYZ. Oh, what have I done? Oh.
Definitely.
This is
Tom
hard.
between
This
moving
is
between
really hard,
languages.
folks.
By the way, this is going to happen to all of you. You're going to start writing define in Python.
So if you wrote something like this, and then you called this foo in Python on 2 is bigger than 1 and 5 and print 7, then you'd see the 7. Because what actually got passed in here is true and 5 and none. Likewise, in here, you got true and 5 and undefined.
So to your question, Shavana, is that print 7 in the parameter of the function gets evaluated, and what gets passed in Python is none, and in Scheme it's undefined, right? Which is why you don't see print 7 twice, right? And when it evaluates to false, because it's undefined, and undefined doesn't do anything.
Yeah, good question. So the question is, how do you evaluate some expression that has been quoted? If I have an unquoted expression, it will get evaluated automatically. If I quote the same thing, then it has not gotten evaluated. At this point, really the only way to evaluate it is to call the special built-in eval procedure, which takes in some code represented as a scheme list and tells you what would happen if you evaluated it. You might think that this is like a really complicated thing, like a function that can just evaluate any expression, but in fact, that's already built into the interpreter anyway. That's exactly what it does, is it evaluates expressions. So it's just triggering that ability that the interpreter already has to treat whatever value is the result of evaluating this part as an expression. Now, it might be that you wrote something that's not legal, like if I try to evaluate 1, 2, 3, it's going to tell me int is not callable. And if I build a list 1, 2, 3, let's say I build it like this, not without quotation, and I say, oh, I want to evaluate that. Let's just pretend it's code. Well, it will pretend it's code, this code, and it will give you the same error that you would have gotten if you had tried to call 1 on 2 and 3. So yeah, eval is a way of taking some piece of data and pretending it's code and evaluating it. And that will either work out or it won't, depending on what the data is. A follow-up question was whether you can evaluate using a comma. Yeah, so I think this question is about quasi-quotation. If you start your quote with this backtick instead of the apostrophe, then you are allowed to evaluate some parts of it along the way. So if instead I didn't have this unquote, I would have gotten this nested structure, but with the unquote, it just says, well, you know, don't evaluate the whole thing, but evaluate this part. And, you know, I could have done this the long way. I could have said, I want to build a list where the first element is 1, the second element is the result of evaluating plus 1, 1, and the third element is 3. So it's not like quasi-quotation is giving me any special power. It's just, it's allowing me to quote something most of the way, but then have some parts be evaluated. And by the way, if scheme is making sense, except for the quasi-quotation part, you should not worry at all. Like this is just some like minor detail, which leads to some cool examples. But mostly you should worry about just quoting and what that means. And or even better at this stage, just make sure you get like define and if making sense, and then you're kind of on track. Yeah, so the question is, can you perform any kind of non-local assignment in Scheme? You know, we had this example of withdraw function. So here's a withdraw procedure, which has some balance. Oh, no, I think it was called make withdraw with the starting balance. And what this did was define a withdraw function, which took in some amount that you want to withdraw. And let's just pretend that there's always enough money. What this was supposed to do was change the balance and then return the balance. How do you do that? Well, there are parts of Scheme that we will not teach you in this course because, I kind of want to teach you enough schemes so that you get the sense that you could learn the rest if you wanted to, but not so much that it takes the rest of the semester. So, so we've kind of picked and chosen, and we chose not to include non-local assignment, but it does exist. It's called set. So if you really wanted to change balance to be the result of subtracting balance by amount, you could do it. And then you could return the balance, and then you could withdraw. And then I think we should be able to withdraw stuff. So if I define my account as, well, maybe we'll call it A, as make withdraw, and I start with $10, and then I withdraw $2, then I have 8 left. And if I draw, you can work your way down. So anyway, you do need this other special form that we haven't talked about called set in order to make non-local assignment.
Am I remembering right, John? I remember when I first learned Scheme many, many years ago, there was some controversy around set. There was people who think you shouldn't use it. Am I remembering right?
So you're right. It's the same controversy that we kind of talked about earlier in the course of the consequence of mutation, is that you lose this notion of what's called referential transparency, which is basically like things are easy to analyze because if you ever have a block of code, you could just pretend that whole block is replaced by its value and you get the same answer. Mm-hmm. And this notion of substitution, where you can like look at some complicated piece of code and you're like, oh, well, this thing, that evaluates to the list 1, 2, 3, and you don't have to think about whether it changes the environment in any way, is really nice. Mm-hmm. For a human trying to understand their own program. And so if you never use set, then you can do this forever. You can just think about any expression is substitutable by its value. Now, this is not true if you start setting things because there's a side effect. So, a lot of Scheme code can be written with no side effects at all. The fact that we never do any kind of assignment anywhere, except for defining some procedures and everything is done with recursion, means that it's rare that you reassign anything ever. Mm-hmm. So that the goal there is just to preserve this notion of referential transparency so that you can think about your program more easily.
Yeah, good.
Yeah, so the question is, do you need to know all the different notions of equality and memorize them in advance, or will we kind of tell you when you need to know? And it will be my goal to tell you when you need to know. In fact, I don't always remember. There's like a number equality, and there's an identity check, and then there's like some kind of thing where if you ask if 2 lists are equal, then it will tell you that they are, even if they were built in different ways. Yeah, okay, so anyway, there's a bunch of different equals, and no, I don't think you need to know the difference between all of them. But right. If you want to know, like this is like this is like nothing that exists in Python because it only works for numbers. This is a lot like the equal sign. Yeah. In Python, I think that just like this will check. Okay, so yeah. This will check whether 2 things are like generally equal, just like in Python. 2 equals 2 is true, and also a list containing 2 and a list containing 2 is true. So yeah, this is usually the one you want, but if you want to check for is, it looks like that, and this is some like weird thing that only works with numbers. But no, you don't need to know it.
Yeah, and I'm going to just reiterate what John's going to say is we're not going to teach you the full-blown Scheme programming language. It's really just enough to get you going, and then the rest, when and if you want to learn it, will come.
But you definitely need to know how like define works and lambda works, and just a handful of like basic arithmetic functions. We usually feed those to you if you're ever like doing a homework or an exam. We'll say like, oh, by the way, there's a 0 procedure that checks whether something's 0. But also list manipulation is something you're meant to know. So car and cdr and cons and list and null and that kind of thing.
This, by the way, is the best part of Scheme is you get to say car and cdr all the time. That's my favorite part of the language.